Hey guys, this is Roya, and in this video I'll be giving you a static friction practice problem. So here we have Charlie and Rose, and they're trying to get into their house, but their dog is blocking the way. Their dog has a mass of 20 kilograms, and Rose comes up to the dog and she tries to push him out of the way, but he doesn't budge. And we know that the coefficient of static friction here is 0.9, and her applied force is 150 newtons. Now here Charlie comes to help her out, and together their applied force turns into 200 newtons, and suddenly the dog begins to accelerate, and acceleration equals 2 meters per second squared. Now using this information, I want you to find A, the frictional force in this scenario, and B, the coefficient of kinetic friction in this scenario. So I hope you've had a chance to try that on your own, and now I'm going to show you how I would do it. So in part A, finding the frictional force here, we know that if we were to draw a free body diagram or force diagram, that all the forces cancel out because the dog isn't moving. This force is mg, this force is n, this force is the applied force, and this force is the frictional force. Now from the equation, static frictional force equals coefficient of static friction times normal force, we see that the maximum force due to static friction is 176.4 newtons. And remember that in this case, normal force equals mg because the dog isn't moving up or down. However, if we were to use this force of 176.4 newtons, we'd see that the dog would actually move backward because the frictional force would be higher than the applied force. Therefore, in this scenario, the frictional force is simply 150 newtons, the same as her applied force. And remember that static friction increases directly with applied force. So in part B, we're trying to find the coefficient of kinetic friction. Remember that net force equals applied force minus frictional force, and this also equals ma according to Newton's second law. So applied force is 200 newtons minus frictional force equals 20 times 2, mass times acceleration. And rearranging some things, we get frictional force here equals 160. Now this equals coefficient of kinetic friction times n, which equals coefficient of kinetic friction times mg, because as we saw before, n and mg cancel out. And here, 160 divided by mg gives us the coefficient of kinetic friction, and that will give us 0.82. Now if you want to see a force diagram, it would look like this. Normal force, mg, and they would cancel out. A small frictional force and a larger applied force.